Section 3.3, Absolute Value Equations and Inequalities. Although here in Math 0306, we really only deal with the absolute value equations part of it, not the inequalities. So to begin, we'll first define what is an absolute value, and by definition, absolute value is a number's distance from zero. Okay, how far something is from zero on the number line. Some other ways we take a look at it is writing it in actual mathematical notation, which is the double bar. We write it as a double bar around a variable such as x or around a number, and we read this as the absolute value of x. So to kind of develop this idea of the absolute value a little bit, if you think about what number is technically 4 units from 0, and well, obviously the number 4, if you go on a number line and count from 4 to 0, you are actually moving over 4 units. Okay, so the number 4 is 4 units from 0, but also the number -4 is 4 units from 0 on the number line. So technically there's 2 answers to that question, both 4 and -4. And that fact there is going to develop this idea that most of these absolute value problems, when you're dealing with a variable, are going to have more than one answer. They're actually going to have 2 answers, both the positive and the negative. So dealing with this absolute value now, in some of the ways you'll see the problems, they might ask you, what is the absolute value of 17? Okay, so how far is 17 from 0 is really what we're asking. Well, 17 is 17 units from 0. -9, how many units on the number line would that be from 0? Well, it would be 9 units away from 0. See, absolute value, because it's a distance, is always positive. Distance can never be a negative value. You wouldn't say, oh, I'm standing 10 feet away from you, but you're -10 feet from me. It'd be, I'm 10 feet from you and you're 10 feet from me. It's always a positive when you're dealing in distances. So now here's where we're going to use this aspect of the positive and negative. We're not given a number inside the absolute value if they're asking you if the absolute value of x, so the absolute value of some number gives you 10, what does that number have to be? Okay, well, that would have to imply that x could be 10, because 10 is 10 units from 0 on the number line, but also remember the negative possibility. -10 is also 10 units from 0 on the number line. So if you took the absolute value of 10, it would be 10. But if you took the absolute value of -10, it would also give you 10. So we technically have 2 answers in a case like this. Okay? And one other thing in this section, we have answers that will be written saying x equals 10 or -10 is the same thing as writing it in set builder notation. We looked at this in one of the earlier sections, 3.1 or 3.2. You'll have x equals, open up a brace, and then have the 2 possible answers, 10 and -10, written inside the braces. And it just means the same thing as writing x could be equal to 10 or -10. Okay, just 2 different ways of looking at it. On some of the My Math Lab homework, they'll have you write it in that form. So I want you to be familiar with it. Okay. So those are some of the basics of absolute values. Now let's get into some of the actual equations, but using this idea that we kind of started to develop up here. So our first example of an equation we need to solve is that the absolute value of this expression 2x plus 1 equals 7. Okay? So here's where we have to remember the idea that if absolute value of something equals 7, then whatever was inside that absolute value could either equal a positive 7 or it could equal the -7. So these 2 equations have to be true. If this absolute value equals 7, then 2x plus 1 either has to be the positive or -7. So now we find our two values, our two answers for x by solving these equations, which is pretty basic at this point. Subtract from 1 from both sides. You do the same thing over here, subtract 1 from both sides. Okay. That would leave us with just the 2x on the left here. 7 minus 1 would give you 6. 2x would be left here. Negative 7 minus 1 would give you a negative 8. Okay. Then dividing by our coefficient of 2. We end up with our possible answers of x equals 3, when we do 6 divided by 2 there, or negative 8 divided by 2 gives us a negative 4. So there are two possible answers. And kind of going back, subtracting the 1's canceled there and there, dividing by 2 canceled there and there. So there are two possible answers, x is either 3 or x is equal to negative 4. And you can go ahead and check. Do these answers actually make sense? So let's plug 3 into this absolute value situation. If you did 2 times 3 plus 1, well, 2 times x, which is 3, plus 1, that actually gives you 6 plus 1, 7. The absolute value of 7 is 7. If we plugged a negative 4 into that same equation, well, 2 times negative 4, and then add the 1, 2 times negative 4 is negative 8, plus 1 would give you negative 7, but the absolute value of negative 7 would give you a positive 7. So both of these end up checking out. So you can always go back and check your answers that way. And any equation, really. Draw a line here to separate our problem. Okay. But those are our two solutions, x is 3 or negative 4. Okay. Our next example, a little bit different situation, because above here, when we just did, we had the absolute value being equal to a number. Here we have the absolute value with some other stuff on the same side equal to a number. In order to solve a problem like this, we always want to move any piece that's not inside the absolute value, we want to move that over to the other side, okay, away from the absolute value. We want to isolate the absolute value before we can use the idea that it either equals the positive or the negative result. So that plus 5, we need to get rid of that. We do that by adding the opposite or subtracting. So positive 5, negative 5, cancel each other out. And on the right side, we have to do the 12 minus 5. Maybe let me write a note here what we're doing. Okay. We want to move any term not in the absolute value. We want to move it to the other side. Okay, that's what we're doing with the subtracting of 5s. So when we subtract the 5s, it cancels out there. We still have our absolute value over here, x plus 3 equals 12 minus 5 gives us 7. And now we have a situation like we did above. We have an absolute value and only an absolute value equaling some number. So what this tells us is that either x plus 3 has to equal a positive 7 or x plus 3 has to equal a negative 7, because either way those two absolute values would get you back to the positive 7. So this tells us, it implies that x plus 3 equals 7 or x plus 3 equals negative 7. Once again, we're just solving these equations. So subtract 3 from both sides. Subtract 3 from both sides over here. You know, they're both solved the same way. You're just going to get a different answer because one is equal to 7, one's equal to negative 7. So doing that, we get x equals a positive 4, or x equals negative 10. And there would be our two possible solutions for that problem, 4 or negative 10. Subtracting the 3 canceled those out. Once again, you could plug these two answers back into your original problem. X plus 3, absolute value, plus 5 equals 12. If we put 4 in there, 4 plus 3 is 7. Absolute value of 7 is still 7. 7 plus 5 is 12. Put in a negative 10 there. Negative 10 plus 3 gives you a negative 7. But the absolute value of negative 7 makes it a positive 7. And then that positive 7 plus 5 again gives you 12. So that's why we have those two possible answers. Draw another line here, separate our problem. Okay. And then moving on to our next example, an even trickier looking one. What if we have a double absolute value? Okay, an absolute value on both the left side and an absolute value on the right side. A little bit tricky, kind of hard to explain why this is the case, but how we handle an absolute value problem like this is that we set the z plus 6, either it equals the positive result over here, 2z minus 3, or z plus 6 is going to equal the negative result of what's over here, the opposite of 2z minus 3. You have to be careful on these though, because we have to put a negative. We're taking the opposite of 2z plus 3, so we have to put 2z minus 3 in a parenthesis. So that's how we can break down a double absolute value equation. So looking at this first one, we'd want to get our like terms on the same side. We want to get our z terms on the same side. We can do that by subtracting a single z from both sides here. And on this one, before we can go ahead and start moving things around, we need to get rid of that parentheses. So we would have to distribute that negative into that parenthesis. That would be our first step. All right. Solving this first equation, z's cancel out. We're left with 6 equals 2z minus z gives us a single z, 1z, and bring down the minus 3. Or here we still have z plus 6 equals, distributing that negative through, we get a negative 2z, and the opposite of a negative 3 is a positive 3. So it really just changes the signs of what was inside that parenthesis. Okay. Our first equation here only has one more step to solve. We add 3 to both sides to cancel out those 3's and get z by itself. Six plus 3 gives you 9.